Hello and welcome to the 12th module of Mastering Engineering Drawing, Foundations to Expertise. In this tutorial, we will demonstrate various methods for the construction of a hyperbola, a fundamental conic section. Previously, we focused on constructing a parabola using the tangent, rectangle and offset methods. These approaches allowed us to master accurate techniques for creating this versatile curve. Now, let's move on to hyperbola. In this module, we will construct a hyperbola using simple geometric methods. The key techniques we will cover are 1. Intersecting arcs method, 2. Rectangle or oblong method, 3. Orthogonal asymptotes method. By learning these methods, you will gain the ability to draw hyperbolas accurately and apply them confidently in technical and design drawings. Let's begin. Hyperbola construction method 1. Let's start with the intersecting arcs method to construct the hyperbola, having a distance between foci of 80 mm and a distance between vertices of 60 mm. First, draw the principal axis, AB, and mark its midpoint, O. Next, position the foci, F1 and F2, on AB, such that the distance between them, F1 F2, equals 80 mm. Also, mark the vertices, V1 and V2, on AB, such that the distance between them, V1 V2, equals 60 mm. Ensure symmetry about the midpoint, O. Then, mark several points at convenient, not necessarily equal, intervals along AF1, for example, 3 points, and label them accordingly, as shown. Now, using F1 and F2 as centers, and with radii equal to distances, V11, V12, V13, draw arcs to provide guides for plotting the final curve. Similarly, using radii, V21, V22, V23, draw arcs from F1 and F2 to intersect the previous arcs. Finally, join all the intersection points with a smooth curve to form the two branches of the hyperbola. This method is a clear and reliable technique for constructing a hyperbola when the foci and vertices are known. It provides accurate results using simple tools, making it ideal for both learning and practical applications. Hyperbola construction method 2. Let's proceed with the rectangle or oblong method to construct the hyperbola, having half of the transverse axis as 50 mm, double orthogonal as 120 mm, and abscissa as 40 mm. First, draw the principal axis, AB, and the double orthogonal, CD, of the specified lengths, ensuring that they intersect at right angles at point, U. Mark points, O, and V, on AB, so that OV equals half the transverse axis and UV equals the given abscissa. Next, use these axes to construct a rectangle, CDEF, where the width and height correspond to the abscissa and double orthogonal respectively. Now, divide the segment DE and CF into equal parts, for example, 4, and mark the points accordingly, as shown. Similarly, divide DU and CU into the same number of equal parts, and mark the points accordingly, as shown. After that, from point V, draw connecting lines to the marked points along the horizontal sides of the rectangle. Then, from point O, draw intersecting lines to the marked points along the vertical side of the rectangle. Finally, connect all the intersection points with a smooth, continuous curve to complete the required hyperbola. This method is a clear and effective approach for constructing a hyperbola when the transverse axis and the corresponding orthogonal and abscissa are unknown. It offers precise results using basic geometric steps, making it a practical choice for both educational and technical purposes. Hyperbola construction method 3. Finally, let's move on to the orthogonal asymptotes method to construct the hyperbola, having a point, P, situated at distances of 35 mm and 50 mm from the pair of perpendicular asymptotes. First, draw asymptotes OA and OB at right angles to each other and mark the position of point, P. Next, draw reference lines parallel to OA and OB, passing through point, P, to form a grid framework. Now, from point O, draw several inclined lines, for example, 6, spaced at convenient, not necessarily equal, intervals to intersect the reference lines. And mark the points accordingly, as shown. After that, from each point on CD, draw vertical lines. Then, from each point on EF, draw horizontal lines to meet the previous lines. Finally, connect all the intersection points with a smooth, continuous curve to complete the required hyperbola. This method provides a clear and structured approach to constructing a hyperbola using just the asymptotes and a reference point, making it especially useful when direct geometric elements like foci or vertices are not provided. That's all for this module. Up next, we will begin exploring engineering curves, starting with an introduction to their types and applications. Thanks for watching, keep progressing through the series and stay tuned for more.